If you think seasons are caused by how close Earth gets to the sun, you're wrong. In fact, Earth is actually closer to the sun in January than in July. So why is the northern hemisphere freezing in January and sweating in July? It turns out the real reason for seasons is something much weirder, a single accident of geometry that's been controlling life on this planet for billions of years. Earth spins on an axis, an imaginary line running from pole to pole. But that axis isn't straight up and down relative to the sun, it's tilted, about 23.5 degrees off vertical to be exact. And that tilt is the entire story. As Earth orbits the sun over the course of a year, that tilt doesn't change direction. The North Pole always points the same way in space, like a spinning top that's been nudged slightly sideways, which means for half the year the northern hemisphere leans toward the sun. Sunlight hits it more directly, days get longer, temperatures climb. We call that summer. For the other half of the year, Earth has orbited around to the opposite side, and now the northern hemisphere leans away. Sunlight arrives at a shallower angle, spreads out over more surface area, and delivers less energy per square meter. We call that winter. Distance from the sun barely matters. The difference between Earth's closest and farthest points in its orbit is only about 3%, nowhere near enough to cause the temperature swings we actually experience. Tilt is doing basically all the work. So where did this tilt come from? Most scientists think it goes back to one of the most violent events in Earth's early history. About 4.5 billion years ago, a Mars-sized object slammed into the young Earth. The impact was so catastrophic it blasted enough debris into orbit to eventually form the Moon. But it also knocked Earth's axis off true vertical, locking in that 23.5-degree lean that's been here ever since. And here's where it gets interesting because not every planet got tilted the same way. Mars has a tilt similar to Earth's, so it has seasons too, just longer ones, since a Martian year lasts almost 2 Earth years. Jupiter, on the other hand, is barely tilted at all, only about 3 degrees, so its seasons are practically non-existent. And then there's Uranus, which got hit so hard at some point in its history that it's now tilted on its side 98 degrees. One of its poles points almost directly at the sun for 42 years straight, while the other sits in total darkness for just as long. Earth landed somewhere in the sweet spot, tilted enough to create real dramatic seasons, but not so extreme that any one region gets locked into decades of permanent night or permanent daylight. That balance turns out to matter enormously. Seasons drive migration patterns, trigger hibernation, control when plants flower and when animals breed. An entire planet's worth of biology is timed to a 23.5-degree wobble. So the next time summer rolls around and it feels like Earth is somehow closer to the sun, remember it's not. You're just standing on a planet that got knocked sideways by a cosmic collision billions of years ago and never quite straightened back up.